Hello, everyone. I'm Whitney Espick, CEO of the MIT Alumni Association, and welcome to the April MIT Alumni Forum. Right now, there are nearly 147,000 MIT alumni living around the globe. Many, including more than some of you who are joining us right now, I am sure, have chosen to live and work in one of the thousands of cities around the globe today. And even if you don't live in a city, it's safe to say that you are still impacted in significant ways by what is happening in them every day. With so much activity within these hubs, economically, culturally, socially, ecologically, and more, and with their ever-accelerating growth, it prompts the question, how can we create cities that best serve humanity and our planet? To demonstrate how the Institute is helping to find answers, we have with us today Kent Larson, who is director of the City Science Group in the MIT Media Lab. He will be joined in conversation today by our moderator, Julie Newman, who is both founder and director of the Office of Sustainability in the Department of Urban Studies and Planning here at the Institute. Welcome to you both. And for all of you out there who are joining us, if you already have questions on this topic, don't wait to add them to the chat box below. You can up and down vote the questions so Julie can know what is of most interest to you all. All right, that's it. Enjoy the MIT Alumni Forum. Handing it over to you.
Well, thank you, Whitney, and I want to thank the Alumni Association for having me today. I'm delighted to be able to share the work that we've been doing at MIT for, now over 20 years. So let's get started. Let me just share my screen here. All right, I'm going to talk about the work that I do at the MIT Media Lab. My group is City Science, as Whitney said, and our work towards finding a new model for transformative urban communities. And I'd like to start with a number, 2.5. Now, what is 2.5? We have lots of numbers in our life, but this is one of the most important. 2.5 tons of CO2 per person per day. This is the yearly average carbon budget for every person on the planet through 2050 if we are to have an 80% chance of limiting global warming to 2 degrees centigrade. All right, 1.5 I think now is kind of off the table. We've crossed that. 17.19, what is that? This is what we calculate to be the average carbon emissions of every person who lives and works in the MIT Kendall Square area. Now that's operational plus embodied energy. That's a long ways from 2.5. So to get to that number, we would have to have a 7x reduction. And, you know, the typical incremental approach to addressing this challenge is not going to work. We need to think about more impactful solutions. Now, the good thing is that what we're finding is those solutions that can dramatically reduce carbon emissions are exactly what you want to do to improve the social and economic performance of a community. But what would it take to get there? Now, we built a local climate model. This is just an interface. I know this looks complicated, but the main thing to realize there where I'm moving my mouse and you see these sliders, these are the interventions that we think can have a profound impact at a local community. And you can explore these in any order. You can do 50%, 20, 25%, whatever of any of these interventions. But for our purpose, we took an extreme approach for this case study where everyone was up to 100%. So first of all, we start by decarbonizing the grid. We just look at the Massachusetts decarbonization roadmap to 2040, which is quite aggressive. And what does that do? That takes us from 17.2 to about 16.3. Then we said, what if every person who worked at Kendall Square and who now commutes in using an internal combustion engine drove an electric vehicle? This is 100% electric vehicles for the MIT Kendall Square area. That takes us to about 16. That didn't save the planet. Then we said, well, what if 50% of workers are remote at any given time? I thought this would have a greater impact. Turns out the people use a lot of air conditioning locally. They drive more locally. That only took us to 15.7. Then we said deep energy retrofit of every building in Kendall Square. Low energy, HVAC, lighting, insulation, glazing, controls, state of the art. Of course, what happens is your embodied energy goes up, a lot of embodied energy, a lot of embodied carbon in these systems. Operational energy goes down. The net effect is about 14.5. Then we said, let's do something even more radical. Let's build housing in Kendall Square so everyone that works in Kendall Square has an opportunity to live in Kendall Square. And by the way, most surveys show that most people who work in Kendall Square would prefer to live locally if there was a quality, affordable housing. That took us down to 11.2. Then we said, well, people still need access to all the amenities of daily life, the schools and shopping and cultural venues, et cetera. If we put that within walking distance, that takes us to about 9. Now we're starting to make some improvement. Then we said, let's do something also a bit radical. Let's make sure that every new housing project has hyper efficient apartments. So we've spun off a company from our group that deploys the architectural robotics for transformable interiors. I'll talk a bit about this more. That takes us about down to 8.5. Now, we've gotten rid essentially of the need for cars because all the amenities and your workplace are within walking distance. So then we prototype lightweight electric mobility that can serve people in local communities. About 8.4, making progress. Then we said, what if everybody in Kendall Square ate a plant-based diet? These are aeroponics, hydroponics near the point of consumption. I'm showing our City Farm project here. That was roughly equivalent to the carbon reductions of 100% electric vehicles. We're now at 6.6. And in the first ring, we deployed photovoltaics on every available surface that we considered appropriate in Kendall Square. That hardly moved the needle, so we have to do something a little more radical here. Now we're looking at high density power like nuclear batteries, or eventually, probably in the 2040s, fusion. So we prepare fusion ready cities. That takes us down to about 5.9. These are the community scale interventions that are most important. But to get to the 2.5, we'd have to decarbonize air travel, decarbonize the internet, get rid of much of the the supply chain for remote manufacturing, have local manufacturing. Maybe we can get to 2.5. But the point is, the win-win-win, the environmental, the social, the economic impact happens at the community scale. All right. So that's essentially our research agenda for my group. I'm going to take you through some of our journeys for many of these systems. And let's start with housing. So we've been working on housing for many years. Probably about 15 years ago, we were working on mass customized apartments where a person could go through a process of delineating what their needs are. They have suggestions about interior modular fit out, or in this case, balcony extensions, and they can put together an apartment using a kind of interface. We did this when the iPads had first come out. Then I thought, well, that's too complicated. Let's do something a little more interesting. Let's make a single apartment that can transform from any state to any other state. So now we have a tiny 200 square foot apartment with a queen size bed, a fully functional office, a dining space for 6 people, a living space for 6 people. We have a small bathroom that can open up to have a walk-in shower and a washer dryer. And we have a kitchen that can expand. We built this prototype on the 6th floor of the Media Lab building. And then we put in, gesture control and touch sensors and threw all the bells and whistles we could think at this. Everything worked. Nothing was faked in this video. When we completed this, we decided we were onto something. We should spin off a company called Ori Living. And by the way, so this had essentially six floor plans, and you could convert from any one to any other one. This is now a 300 square foot apartment where you can see the beds coming down from the ceiling. It has a micro kitchen, a walk-in closet on demand, or a guest room, or a small child space. So, rather than having a bedroom and a living room, you have a single space. In this case, it converts from living to sleeping. This is the company that we spun off, Ori Living. We're now in 100 buildings in over 30 cities. We have our funding from 2 large companies, Alphabet and IKEA funded this work. So I think now we're exploring what this future might be. This is an apartment we have in New York City in Hudson Yards. You can see the bed coming down from the ceiling. I stayed there a few months ago. An office on demand, and it collapses in the evening. So you have a larger living room or an office on demand. That's me. Now, it's not just the small apartments. You can have much larger apartments, small, medium, large, extra large. But if you deploy transformation like we're talking about, you can essentially double the functionality of any given space. We're working on reinventing the hotel room. We have a partnership with Marriott now to do that. Again, beds come down from the ceiling. Now, it's very interesting also, if you're dealing with housing for particularly the frail elderly, this comes in very handy to create, in this case, a kitchen with low counters and a 5-foot wheelchair turning radius, but then maybe her partner has a bad back and he uses a walker, so the counters go up and the space becomes more compact, so there are graspable surfaces if you lose balance. Lots of applications for these ideas. Journey 2, mobility. We started this back in 2003. This is the city car that had 4 innovations. It had robot wheels, drive motor, steering, braking, suspension in each wheel. It could spin. It would fold, so you can occupy. You can park rather 3 of these in one parallel parking space. You have front egress. You step directly out on the curb. We build a full-scale prototype of this vehicle. We tested it on the streets in Spain. It had all of those 4 innovations I talked about. But when we finished this, we realized that it was still a car, and the future of cities was communities without cars. And if you move towards autonomy, you didn't ever need to park this vehicle in a high-value part of the city. So then we looked at lightweight autonomous vehicles and how these vehicles could communicate in a more natural way with people in the community. So this was what we called IVITA, Autonomous Electric Vehicle Testing Array, that we finished in 2013. And by the way, some of the car companies licensed this technology. Then I said, well, we can push it even farther. Most trips in the city are 1-person, low speed, short distance. So let's build a 1-person, low speed vehicle that can operate legally in a bike lane. And if you see these 2 women, they were not threatened by it. She has a big smile on her face. So a lot of what we were doing is trying to design these vehicles so they could be good citizens in the city. We then brought some of the earlier explorations into this vehicle where the headlights could make eye contact with you and signal its intention. You would call for this vehicle like an Uber. It comes to you wherever you are. Now, the human controls it and provides human power to the system. We call it a persuasive electric vehicle because it persuades you to get more exercise and to use a more sustainable mode. We're now looking at how a single vehicle can transform, again, transformation from a people mover to a package mover, and we're modeling the impact of these in the city. Then I thought, well, we can push it even farther. Let's work on bicycles that you can call like an Uber. So this is a conventionally driven bicycle that dynamically converts to a tricycle. So here's Naroa, my PhD student who actually built this vehicle, riding it, converts to a three-wheel, and it goes off to pick up the next person who calls for it. Journey 3, understanding complex human dynamics. This is absolutely essential if we're going to design human-centric, high-performance communities in the future. Back in 2004, we built the Place Lab, which is still, I think, the most highly instrumented living environment ever built. We literally had hundreds of sensors. We knew where people were, what they were doing, the state of the environment. We could introduce new systems. People would volunteer to live in this environment for several weeks at a time. We had all our IRB approvals in place. And we were testing systems that could proactively encourage health behaviors. We did this the first year the iPhone came out, long before Fitbit and others developed wearable health-related technology. We called this EveryFit. And we instrumented people going through their gym activities. We worked with IKEA to instrument a living lab in Malmö, Sweden. Here you can see all of the sensor locations in the kitchen of this apartment. The bouncing ball shows the sequence of sensor activations. We know what systems people interacted with, what they did not. This helped IKEA design better appliances and cabinetry for the home. But what we were particularly interested in were the health-related behaviors that could be revealed. We spun out a company called Butler Technology that's now commercializing this kind of sensing and taking it to scale in architectural environments. Journey 4, food production near the point of consumption. Back in 2015, we built the City Farm, that is a aeroponics, hydroponics facility where we could systematically test technology. Here you can see our farmers monitoring, in this case, the lettuce and the basil. Here are the roots that are misted with that hydroponic system. I have 4 hydroponic systems in my home, and I continue to do experiments. This is lettuce growing one winter over several days, and down in my basement, I'm growing hydroponic tomatoes. So I'm a big believer in food production near the point of consumption. I've done all kinds of experiments comparing this to tomatoes and lettuce grown in soil, and I'm convinced this is the future, at least for high-value produce. Journey 5, urban modeling and consensus machines. I don't care how good the ideas are for cities in the future, unless you can bring people together and reach a shared vision of what the future is, nothing will really change. We like to use Lego bricks for modeling. This is where we started, just color-coded Lego bricks, where blue was water, green was parks, yellow was housing, etc. Then we started projecting onto white Legos. This actually was pretty effective, where you can see mobility modes and land use, solar radiation, wind flows, geolocated tweets that reveal the density of human activities. Then we took it a little farther. We said, let's use optical tags to so we can create dynamically reconfigurable environments. I love Barcelona. We have a lot of Spanish people in my group, so we modeled Barcelona here. And here you can see how land uses, in other words, apartment buildings, for example, that have different profiles of people housed in them can be relocated. What the dots are showing are millennials in blue and mid-career in yellow, affluent senior people in red, and we can get some sense of the human dynamics in the environment. Now we're doing much more sophisticated work. This is Kendall Square, where you can dynamically reconfigure land use and density and toggle on all the mobility systems that we've been working on and get real-time feedback as to building energy and innovation potential and safety and security and the like. Now, how we use these platforms in real-world projects, we've had many around the world. This is in Boston, where a new bus rapid transit system was being proposed. And it was very contentious because you're taking away drive lanes for cars. The typical community engagement process is often experienced as something like this, where the angry voices dominate. We tried to turn that around. We built 3 city-scope platforms at the regional scale, the community scale, the street scale. We located them in the community center in Dudley Square, where many of these lines were crossing. And we did a series of community engagement projects collaborating with the city of Boston. So here you see the touchscreen. This actually didn't work very well, but people could locate where they lived, where they worked. It required a PhD student to explain how to use it. This was much better. Here, this was a Lego table where people could move these Lego bricks around to different station locations, and then see the impact. Or here, the gold standard with the station in the center. We could remove parallel parking and replace it with bike lanes and get community feedback. They could see the impact on the throughput of buses and bikes and cars, and so they could make informed decisions. Actually worked quite well. These are some of the city-scope platforms that we've built around the world. We've also worked commercially through my spin-off company on some of these projects. This is a urban simulation center in Shenzhen, where they're using this to model each new district of the city as they're planned. We build a similar platform in Hangzhou, China, for a new central business district. For these kind of platforms, the most traction we're getting, frankly, is in Asia and the Middle East. These are the places where there are these large urban projects that can take advantage of these kind of new platforms. Informality. What is that? Well, we're very interested in informal settlements, particularly in Latin America. This is one of our collaborators, Eva, and she's managing her water. And you can see that she uses buckets. She has no central water supply. She has no hookup to a sanitation system. She has illegal power. And we spent a lot of time with her and other people in the community trying to understand how they use water. She collects water in different ways, in a cistern and in buckets. She uses different water sources for washing and bathing and for drinking. So we created these sensors that could give her information about her water consumption. This is the interface that we use. We have a mobile phone version of this, and she can monitor water levels and water quality. And it's simple enough to use that she has her grandchild now monitoring her water. And in this informal settlement, Lomas de Centinela, now there are many other people in the community that would like to have a similar system. So sometimes it's the low-tech solutions that are the most impactful. This is another project we're working on in Chile, in Concepcion. It's an informal settlement of the Mapuche people, where they settled on a garbage dump on the edge of the river. They don't have land title. They do have power here, illegally tapped, but they have no sanitation, no community water. We did a series of workshops with people in the community, and now we're helping them get land title and helping them plan their community and hopefully become entrepreneurs and develop their property that on this former garbage dump that they've inhabited for over 100 years. And I'm quite excited about where this project is going. Journey 7, new rules for low carbon entrepreneurial communities. I think of all the things that we're working on, this has the potential for being the most impactful. And it's focused on zoning. Zoning, I think, is one of two platforms that we can take advantage of, public policy platforms, to change in a fundamental way our community, the other being taxes. But zoning is underappreciated. This is the Seagram's building in Manhattan. 1958, Mies van der Rohe set it back from the street, created a plaza. Nobody had ever done this in Manhattan before. So when they rezoned the city, developed a new zoning code in 1961, they decided to build in plaza bonuses. So they would give developers a bonus if they would put in a public plaza. They create more high-value space, have more revenue. They did something for the public good. Almost overnight, every developer in the city was putting in plazas. We thought, well, let's tap into this basic idea by giving developers a bonus, but let's do it in a dynamic, fine-grained way where we can delineate all the different types of housing or amenities that are needed, give developers a bonus for that, but make it dynamic. So you could start out with, say, a 40% bonus for certain types of amenities or a 20% bonus for certain types of housing. But as each project is built, these incentives are dynamically adjusted. What this does is it creates feedback mechanisms that are something analogous to a natural ecosystem in harmony, similar to predator-prey feedback mechanism. We don't have those kind of feedback mechanisms in city. We have market forces that are great at optimizing the profits of the landowners, but we have no feedback mechanisms that optimize social and environmental performance in cities. So through such a project, you might over time increase the housing and achieve the housing and amenities and put them in harmony with the jobs and achieve something that might be considered civic homeostasis. Dynamic equity sharing. Well, one way to get the community supportive of such a process is you take that increased floor area and you put a percentage of it into a community endowment. The value of that project's a function of the community that it's in and the net effect of all of the actions of everybody that lives in the community. And then you could share that endowment according to certain rules. It could be your proximity to a project. If you're close to a project and will be impacted by it, maybe you get more of the endowment. It could be a function of your time in the community, your financial need, how much you volunteer, whether you live and work in a district. And that community could make the final decision on the density. If you increase the density, though, you get more into the endowment. If you lower the density, well, maybe it's more in keeping with the character of the existing community. And this way, the community is engaged in a creative, productive way, kind of a co-creation process that I think would be much more valuable. And Journey 8, generative AI for cities. So we could take that same kind of project and bring to bear all of these generative tools that we now have, and create a much more of a rich feedback mechanism for this community engagement process. So maybe a low density project, the endowment is $3 million, maximum density $22 million. But there's no reason why developers can't license design engines from in the future from architects. And if this construction method was more expensive, maybe it reduces the endowment by 5%. Maybe this is more efficient and increases the endowment by 5%. We're now building these generative AI theaters where people can go in and interact using voice commands and explore these possible futures. In this case, it's the formal and the kind of aesthetic impact of that. But there are other things we can do as well. We can use these new tools to develop much more effective agent-based models. This is a simple example of how we can create very fine-grained profiles of people in the future. This was a profile for somebody working at the Media Lab. Or we can then generate their itineraries. We don't have access to all of this data right now. We can develop Python code in an automated way. We're just beginning right now to tap into the possibilities for these future generative systems. And then ultimately, we can create an agent-based model where we can look 1 year, 5 years, 10 years, 20 years into the future and begin to model the human dynamics and the impact on the consumption of energy, the CO2 emissions, the economic performance, the social performance of communities in the future. And I'm using it personally. The last summer, my wife and I visited Kyoto, and I just loved how this temple was nestled in the garden. So I'm using these tools to explore a house that I'd like to build in a couple of years. And this is just one AI-generated image of that possible future living environment. Journey 9, building an international network of city science labs. So we now have created 10 city science labs around the world. This allows us to leverage the work that we do and have more impact globally. We're in South America, North America, Europe, the Middle East, and in Asia. And we're now trying to expand into Africa and India. And we're working on funding models to allow that to happen. And finally, Journey 10, building an anti-disciplinary team. We now, in my group, have people from 12 different countries, from many different disciplines. In fact, they're from architecture, urban planning, mechanical engineering, electrical engineering, computer science, mathematics, cognitive psychology, and industrial design. And we could never do the kind of work we do in my lab unless we created this kind of transdisciplinary group with people from all over the world with different experiences. I think of it as anti-disciplinary because I think just getting disciplines to work together is not enough. We have to actually break down the boundaries between disciplines. All right, so that's a summary of the work that we're doing. And now we're going to bring in Julie Newman. She's director of the Office of Sustainability, a lecturer with DUSP, that's Urban Studies and Planning. She and her team are solving global sustainability issues at the local campus level. Julie and I have worked together on a project in the past, and I'm sure we're going to work together in the future on many of these ideas. So she's our moderator today for a Q&A. So if you would, place your questions into the Slido, and we'll get to as many as we can. So hi.
Hi, Kent. That was fantastic. Well, thank you, and really glad to be here. It was a great presentation. It's such a wonderful way to reconnect with you and your work as well. So I'm sure, like much of the audience, I'm absolutely inspired. I also inspired not only by the presentation, but just a reminder of the methodology, the relevancy to the issues in the state of the world at the municipal level. I still dream of a model of MIT for us to work on together. So maybe that will be the outcome of this, is to revisit that, because I think when we last met, we weren't committed to decarbonization at that point. So what's really fascinating?
Right. I remember pushing you really hard to think about that, and to think about housing as a solution.
Exactly.
You know. So that's exciting.
Yeah. So I think we've in parallel kind of reached these places, and I think it'll be time to come back together again. So as Kent stated, his city science research group proposes that new strategies must be found to create the places where people live and work, in addition to the mobility systems that connect them in order to meet the profound challenges of the future. And as Kent said, that's how we connected years ago. Um, and I think we both recognize, and this is where we'll head into some discussion, that we really must solve at the systems level and the individual scale concurrently. And that was a lot of what your story told us. Here's how individuals interact, but here are the systems that must be put in place. And that's very parallel to the way we think about sustainability and climate action on the campus. So at times people think the campus is small, but we really think about it in parallel to as a municipality with so many systems that we manage at MIT. So I'm going to jump into a series of questions that have come from the audience, and then we'll just open it up and see where that takes us. Okay. So I want to start off as I'm going to start off with this one question drawing from your presentation that, at MIT, we tend to think very globally about solving for climate change, right? That's the message that tends to come out. Yet your presentation really focuses on the importance of municipal scales. And, as you mentioned, in the context of the grid and the context of the regulatory environment of municipal scales, and the infrastructure, and then the choices individuals make. So can we begin by you talk about the importance of solving for decarbonizing the world, if you will, but at the municipal scale, and how that can then go back and inform global scale solutions?
Well, so let me ask you a question, put you on the spot here. What percentage of global emissions do you think come from urban areas?
Oh, that's a fantastic question. I'm going to say 75%. Well, industry plus industry, right? Yeah.
Yeah, the latest IPCC report estimates 67 to 73%.
Oh, I was very close.
Very close.
Yeah.
Most people say 20 or 30%. It's amazing.
Oh.
So, so the reality is, let's call it 70% of emissions come from urban areas, right?
Yeah.
The root causes of global warming, the primary root causes, I think, are a function of decisions that are made at the local level. And I do not believe that increasingly dysfunctional national governments will ever solve this problem. I mean, I just don't believe it. I mean, just look at all the promises from COP28 compared to what is likely to actually, take place at the national level. But on the other hand, national governments don't really address the root causes. I mean, the root causes fundamentally are settlement patterns. It has to do with zoning and building codes and the kind of local infrastructure that's implemented. I mean, it's why I start with zoning. If I had more time, I'd go through the history of zoning.
Of course,
and how the Supreme Court validated zoning in 1927, which happened to be the same year that the 15th million Model T Ford rolled off the assembly line. And the combination of cheap cars and zoning, the separated functions, housing, and office and industrial, and cars to connect them, led to the kind of low density sprawl and just tremendous waste of energy and CO2 emissions. And that was a response to some of the real problems of cities at the time. And I think people at that time were making rational decisions, but it's just not working for us anymore. And so rethinking zoning, having some kind of rational tax policy that creates proper incentives, but increasing the nodes where people can live and work and have access to amenities, including in suburban areas. I mean, you see suburban areas growing these little villages, and people are moving around there. They're building multifamily housing. Even in the South, I see that happening in red states. So anyway, the point is 70% of emissions are local areas, and leaders and local communities have the power to address what are the root causes of climate change.
Yeah. I think that'll be an area for you and I to circle back with, outside of this call as well, because I think that's a lot of where MIT's commitment and your research work really intersect. That could better inform some of the work that we're all doing together. Before
Right.
I move on, we've got some wonderful questions from the audience. I have given who is in the audience, my guess is some of us are thinking the same thing as, and if you can't answer it, maybe it's a follow-up, but do you have a book or a reference? I think that's a really interesting point you just made in terms of looking back on the history of zoning and development in cities. Is there a book that you might recommend that audience members would be interested in following up with to learn more?
Yeah, well, there are a lot of good books out there that are very specialized. I mean, the kind of the more accessible book that I would
Yeah.
recommend
Uh-huh.
is Ed Glazer's Triumph of the City. I think that's a really, really
Oh,
good
that's
book.
supposed to be very good.
No, it's a great book. Ed is the head of the economics department at Harvard. And,
Okay,
he's a
excellent.
serious scholar looking at housing policy and tax policy and all of that. But he wrote a just a great book on cities. I'd probably start with that. Another, which is kind of the Bible, is
Mhm.
the Death and Life of the Great American City that was written in about the 1960, I think 1960 it was written. And that's another reference. That was,
That's great.
fighting the trend towards heavy infrastructure and auto-centric development, and
Yeah,
is that there was a much more human-centric way of doing
yeah.
that.
Don't you find that looking at those root causes really can help inform some of the
Oh, yeah.
solutions we're building today? So I think that's an interesting outcome from
Yeah.
today for folks who are on the call with us.
Well, one criticism I have of how MIT is approaching the climate problem is that it's a bit too heavily focused on, technology magic bullet fixes. I mean,
Mhm.
people understand that it's a societal problem. We have to do a lot more, and
Right,
and
right.
I'm not saying it's exclusively that, but I think just because of the nature of the research that's being done at MIT, it tends to fall into technology solutions that are incremental. 3% better battery chemistry,
Right, right.
like that. And we need it all. This is an all hands on deck problem.
It
But I
really
think
is.
there
Yeah.
needs to be more focus on some of these more systemic root
Yeah.
causes.
Great. Well, it'll be good to circle back. I'm gonna just circle back to some of these questions because there's some good
Mhm.
ones. Well, one is just actually helps frame some of these. There's a question just saying, could you, before we jump into the rest of the questions, it says, could you please provide a little bit clearer definition of what we mean by a smart city, or what, sorry, rather what your research group, how you define smart city for your
Yeah.
group.
I never use the term smart cities. I noticed that
Okay.
that crept into the title of my talk. But,
Okay.
but frankly, I hate the term because it gets back to, it's kind of been co-opted by companies as a marketing term. And again, it gets back
Mm-hmm.
to the kind of, you know, technocentric solution rather than, thinking about, human dynamics and economics of cities. The classic definition of smart cities would be sensors and computation to optimize systems. Traffic
Mm-hmm.
lights that are in better sync, so you get a greater throughput of traffic, and the like. Um, People have tried to broaden it. There for a while, I saw human-centric smart cities as kind of a branding
Mm-hmm.
label. I just think it's too narrow because it just implies there are technology fixes, and I don't believe there are.
Right. Actually, that's a good segue to a couple of questions. There seem to be some questions coming in that are actually asking about that human dimension,
Yes.
which you very much emphasize in some of your points toward the end. So they're saying, how do your city designs? I'm going to try to merge a couple of these. How do they promote human well-being? Is one of the
Okay.
questions, and as a follow-up, there's a question around, how do these technologies and innovations affect cost of living, and how does that then affect diversity? So it's a three-part question. How do your designs and what you're promoting
Mhm.
advance human well-being? how does it affect cost of living? And then that leads to, the question that's on a lot of people's minds is around affordability and diversity of those
Okay.
centers.
Well, so let's take the Kendall Square example. 42,000 people commute into Kendall Square every day by our numbers, which means they leave every night and they
That's
go
right.
back to wherever they live.
Uh-huh.
And they spend a lot of time in automobiles.
Yeah.
If people lived and worked in the community, and like I say, most people surveyed in Kendall Square, I think it was like 95% people in the Cambridge Innovation Center working on startups would prefer to live near where they work. Then there's 24/7 opportunities to exchange ideas, right? So people meet in restaurants and in bars, and they meet for breakfast, and they meet at the gym, and what that does is that increases the innovation potential of the community. All right.
Yeah.
They're also, if they live in a walkable community, they're getting more exercise. They're riding their bikes more. They're walking more. That, of course, increases the public health. It reduces rates of obesity, better outcomes with respect to congestive heart failure, all of these things. It also increases social ties. So people get to know each other, they live and work in the community. And I think that would help reduce polarization and conflict. It means that unlike Kendall Square, which is just completely dead in the weekend, right? You've got more activity at night and on weekends, which increases safety and security.
Sure.
It promotes more businesses locally, so people spend their money in the community rather than where they live, right?
Sure.
And so that builds wealth in the community, which creates more economic opportunity. So I think the outcomes, environmental, of course, CO2 emissions, like I talked to, go down. So the outcomes socially, economically, environmentally are improved. It's a win-win-win. And then if you have the kind of rational housing policy with incentives, build affordable housing for the entire workforce. I mean, I think teachers who teach in the local schools should live in the community. No teacher who teaches in Cambridge lives in Cambridge, essentially. Or the police force or the firefighters.
Right.
The maids that work at the Marriott, they should all have an opportunity to live in that community. And you could do that with housing policy. That increases the diversity. And then of course it lowers the cost of living if you do it properly. The main reason we worked on the architectural robotics is to lower the cost of housing in high value urban areas.
I see.
So, a cost of an apartment now, a condo is, something like $1,000 a foot in many areas. So if you can create a 300 square foot apartment, functionality of a 600 square foot apartment, you're saving $300,000, cutting the price in half. Then maybe you add $25,000, $30,000 for the technology, but you come out ahead. So
let me just interrupt there for a second, because I think that there's a lot of related questions that I think people are really curious about this model. And there's another question around, this notion that people like to live separately also, in detached housing, to have a yard, a place for our dogs, a safe fenced in area for kids and dogs, So the question is, following on your train of thought, there's how do you get people to want to move to these areas of greater density? And I think you've just answered it in terms of this notion of being able to work and live in the same place. But how does your group think about that? You had a point around the human component.
Okay.
I don't remember which number that was. I want
don't
to
either.
say, yeah. But anyway, I think it really builds on that.
I mean, first of all, we're not forcing anybody to leave the suburbs.
Of course, yeah.
What I'm focused on is making urban areas affordable and more livable for people that want to live in the city. And increasingly, that's most young people. And but I know a lot of married people with young children, they'd love to live in the city, but there aren't the playgrounds, there aren't the schools. Childcare is too expensive. If you could solve that, many of those people would love to live in the city.
Yeah.
If we have the proper parks and et cetera, then you got the connection to nature. Sure, I grew up in the suburbs. I know the pleasures of living in a house and having a yard
Yeah.
and being close to nature and having the freedom of a car. I mean, I get that, but that's just not a sustainable future
Yeah.
for at least at the way we're going now.
Sure. Again, the questions that are coming in are excellent. So I hope you get a chance to look at. I know we won't answer them all. Let me just share a couple and that you can kind of weave them together. There's a
Okay,
series of questions saying, how do we address the economic cost of this technology? Is it geared towards the affluent citizen? And that's coming out a couple of times. And what are the incentives needed to reach these solutions that you're aiming at? And undoubtedly these are all questions that you've faced before, but these seem to be of high interest to folks around incentive, cost, engagement with folks, in
sure.
terms of what audience you're targeting.
Well, first of all, I mean, I think that the kind of technology that we're working with, for the most part, um, would not increase people's costs.
Okay.
I mean, like I just talked about, if you could live large in less space in the city, the cost of housing is basically a function of the area. If you don't need to own a car and you can use lightweight shared mobility, the cost of autonomy, what we call light autonomy for these lightweight
Hmm.
community vehicles is minimal. If it was taken to scale, much less than the cost of creating an autonomous high-speed vehicle that can drive in
Hmm.
all conditions everywhere. I mean,
Sure.
we're a tiny fraction of the cost, and for most people, the car and the home is their greatest expense. And then
Yeah.
you don't have the cost of commuting, that's
Right.
there.
Hmm.
It is really about incentives. I mean, I think this is basically
Yeah.
the big challenges are behavior change, and
Okay.
you need to change behaviors, I think, in three different ways. One is change
Hmm.
the behavior of the property owners and the developers and the companies that
Yeah.
that create infrastructure.
Sure.
And zoning is what we're advocating. I think
Hmm.
a carbon tax is another way of doing it. Um,
Yeah.
Also need to
Good point.
change the behavior of people with respect to um, approving, supporting projects
Hmm.
in their backyard, countering this not in my backyard NIMBY knee-jerk
Yeah.
opposition to everything
Uh-huh.
development.
Yeah.
So our solution to that, we'll see if it works. I hope to try it, is to share the wealth. And so
Oh,
somebody building a large project in your backyard, well, you should get a piece of it. And there are lots of ways to do that. I mean, I talked about the endowment, literally could be fractional ownership of those projects. And I think, if we're looking long term, the impact of AI on jobs, I think probably equity and property ownership will become more important than wages.
oh, interesting.
And so that's a way to share the wealth. Uh, and that you need to, and then there's personal behavior change, just acting in a virtuous way.
Hmm.
Unfortunately, that has a negligible impact on CO2 emissions.
I see.
The other two have a much more profound impact, but we
Sure.
should all behave virtuously. So, that's part of the mix as well.
Yep. Just let's see if we can squeeze in, two or three quick questions here. One, because this builds on what you're saying in terms of living is, do your designs tend seek to optimize? I think we probably all have the vision of of the Lego models and the light models you were building.
Yes.
Maybe speak a little bit more to how your designs optimize for green areas so cities don't become concrete runways with buildings, but they are designed to include trees to reduce temperature,
Sure.
engage with, reduce heat, health risks related to heat.
Sure. Well, so first of all, we've done a lot of work on mapping amenities to human needs. So
Mhm.
we use telecom data, or we refer to standards in Europe because they're way ahead of the US in terms of the
Sure.
amount of, the amenities that people need. One of those, of course, is parks, and there are different types of parks. So
Mhm.
in our model, we know what the optimal kind of, you call it utopian mix of amenities would be for a given population. You
Okay.
know, coffee shops, bodegas,
Mhm.
schools, co-working, dog parks, et cetera. I mean, we've got a long list, and we know the area per person that would be ideal for all of these, and we can build all that into the model. I mean, we're not creating an AI generative system that just, has a machine create that. We believe
Mhm.
in a kind of what we call extended intelligence, where we put these tools in the
Mhm.
hands of the community. They can make the judgments about the amount of parks they want.
Yeah.
I mean, that's not for us to decide or some
Right,
AI to
right.
decide, but they
Yeah.
need to know when they're below the standard and
Mhm.
when they're converging on an optimal system based on their values.
That makes a lot of sense. I think there's been some great work coming out of New York City and some other progressive cities looking at the distance between green spaces, what that ratio should be for a livable block.
That's right. It's
Yeah.
not just the area, but it's the proximity.
The proximity, exactly.
And
Yeah.
so all our metrics are, you could think of as, they're the social, the economic, and the environmental, but it's also with respect to the density, proximity, and diversity.
There's a great question here, so many, but there's a really good one here, Ken, asking about these. I think we're all hearing more and more about these office buildings that have
Mhm.
emptied out post-pandemic with a hybrid work environment. Are you considering how those spaces may become configurable over time? In this case, somebody is saying there's an urgent need in Chicago, but I think we've also heard the same thing. We're
Yeah.
hearing more and more about that being converted to housing in Boston. What are your thoughts on that?
I think they should be. I mean, I actually think central business districts are dinosaurs. They're obsolete, meaning, these single function office areas that only operate 9 to 5. I mean, those need to go away.
Yeah.
And many of these buildings are sitting empty. All these Salesforce buildings that they built recently in San Francisco, most of them are empty.
Yeah.
The problem is it's not an easy problem to solve
No,
because
it's
core
not, is
plates are
it?
very deep. You tend to have a core
Yeah.
in the center and a lot of space from the core to the window. And so it's not practical to have a really deep apartment with only
Yeah.
glass on one end. So it means to really make them work, cutting out big openings,
Yeah.
create light wells in these buildings, and that's very expensive. The older buildings are easier to convert than some of the newer buildings.
Mhm.
But that'll happen. That'll happen. It's
Yeah.
just expensive, and many of these buildings are just not, they're not
Yeah.
economical to convert. They probably eventually will
Right.
have to be torn down with better
Yeah.
designed housing, replacing them rather
Right.
than to try to do conversions.
It's really interesting, though. I mean, that's really a pivot that we see, a potential pivot in terms of your push for housing and
Yeah.
empty buildings, right? So that'll be something, maybe that's part two of a future series as to what is that evolution.
I really think we're living in an exciting time. It's like we
Yeah.
hit a big reset button with the pandemic,
Yeah.
and we're getting serious, and we're starting to think more rationally about. I'm talking specifically about cities,
Yeah.
But what is work in the future? Where do we want to live?
Right.
What is a school? What is a hospital? I mean, all these things are up in the air now with
Yeah.
everything changing so quickly, and I'm
Yeah.
I'm hoping we'll settle into a much more
A new
equitable,
pattern.
high performance,
Oh, yeah.
entrepreneurial future.
That's a perfect place to end. So that's actually all the time we have today. I really want to thank you, Ken. It's so wonderful to reconnect with you. This has been so thought provoking and inspiring. And I, probably like many others, I can't wait to learn more. I'm going to go look up that book this afternoon.
Okay.
I also want to thank the MIT Alum Association for organizing this program and bringing us all together. And if you want to learn more about what we're doing at MIT to address the issues, come to the Office of Sustainability website There you can review ongoing efforts and commitments at sustainability.mit.edu. So thank you so much for your time, and we'll see you again.
Thanks, Julie. Thanks, everyone.
Thanks, Kent.
Bye.
Bye-bye.